Energy. Energy is everywhere. It is the one unchanging constant of our universe. This is known as the law of conservation of energy. In an isolated system, the total energy cannot change, it can only be converted. In our universe, the total energy cannot change. Now, say there was a second universe that was siphoning energy from our universe. The final energy of that universe would be higher than the initial energy, while our initial energy would be higher than our final energy. But still, this wouldn't violate the law of conservation of energy, as the total energy of the two-universe system would be maintained. Energy comes in a variety of forms. We're all familiar with mechanical energy, mechanical kinetic energy, and mechanical potential energy due to gravity. There's also elastic potential energy, electromagnetic energy, or radiant energy, stored chemical energy, energy that is held in the bonds between atoms and molecules, and field energy, energy of a particle in relation to something emitting a force. But what is energy? Energy is a property of objects, transferable among them via fundamental interactions. It's measured in joules, which are based on the amount transferred to an object by the mechanical work of moving it 1 meter against a force of 1 newton. That's all very interesting, but why should I care? This is the theory of relativity. It states that any matter has energy relative to its mass. So, you are energy. Unfortunately, humans can only use energy in certain forms. You eat food, which has stored chemical energy in the bonds between atoms. You also use electricity and technology to make your life easier so that you don't have to do manual labor all day. Unfortunately, you have to generate that electricity somehow. It heats your home, turns the lights on, keeps you warm at night. Certain energy sources are favored for the production of electricity.
According to information given by ComEd, Chicago receives most of its power from 4 main resources. They are coal, nuclear, natural gas, and renewable energy. So how much of these resources are distributed throughout the city? Well, 44% of it is from coal, 40% of it is from nuclear, 12% natural gas, and 4% renewable energy.
In a coal reactor, coal is burned to generate heat, which turns water into steam. Steam is sent through pipes to create a pressure differential on a turbine, which is turned to generate electricity. Nuclear reactors use the same mechanism as coal reactors for the generation of electricity, utilizing water heated into steam as a means of transferring the energy from the fuel to the turbine. In this case, the fuel is fissile uranium. Because the fuel sources we use for these types of electricity generation are limited on Earth, in the future, humanity will have to transition to alternative sources for electricity generation.
One way to generate electricity is through the conversion of solar energy. Solar energy is energy obtained from the sun's radiation. Sunlight is comprised of extremely small particles called photons. These photons carry the radiation energy and convert to electricity at the atomic level. The amount of energy converted depends on the type of material that the light is shown on. Some materials exhibit a property known as the photoelectric effect that causes them to absorb photons of light and release electrons. When these free electrons are captured, an electric current results that can be used as electricity.
We can use the following equation to calculate the energy of photon radiation of a wave with known properties. S is the instantaneous energy imparted on a given area. It's equivalent to the inverse of the speed of light times the magnetic constant times the magnetic field strength of the wave squared.
The photovoltaic system is quite logical. First, the solar panels convert sunlight into direct current, which is then passed onto an inverter that converts the energy into standard household alternating current. Finally, the system uses a utility meter that spins backwards when the solar electricity generation exceeds the house's electricity consumption. One of the most important components of a solar cell is silicon. Silicon is a semiconductor, meaning that it has a mix of the properties of metal and an electrical insulator. As the photons in light touch the silicon atoms of the solar cell, they transfer their energy to loose electrons, knocking these electrons off of their respective atoms. The photons could be compared to the white ball in a game of pool, which passes on its energy to the colored balls it strikes. As the electrons are freed up, they are grouped together in order to create an electric current. The solar cell achieves an electrical current through the creation of an electrical imbalance, forcing electrons to flow in the same path.
In order to calculate the total energy output of a solar array, we use the following equation. The total energy output is equal to the total array area times the yield percentage, or efficiency, of the array, times the solar radiation average, times the performance ratio coefficient for the specific array.
The ongoing argument between scientists and specialists is that solar energy will be the main source for powering our homes, as well as businesses and factories. An average 1,500 square foot single-family home uses up to about $100 a month worth of electricity. There are 3 current common applications of solar energy, the first being photovoltaic cells. These cells can be used as roof tiles. They cover the roof of a house and take advantage of the light coming from the sun. This is beneficial because by locating photovoltaic cells on the top of houses, no extra land or space is needed, and they can also be situated in urban areas. The technology now needed is about 90% cheaper than it was in the 1970s. The second application of solar energy is the intentional design of buildings to collect the sun's heat. Buildings are designed sensibly, facing in a way where they can use the sun to the maximum benefit. The large glass windows are good for the winter when the sun is very low. Balconies and trees protect the building from getting too much heat in the summer. The third common use of solar energy is the use of the sun to heat our water pipes. The pipes are painted black and put in a greenhouse-type insulator to heat the water supply. This reduces the cost of electricity spent in heating water. Are all of these options really as easy and feasible as they sound? No, unfortunately not. Solar panels take up a lot of space. Also, during the nighttime, as well as on cloudy days, the capability for a solar panel to generate electricity is greatly limited. The final issue with solar panels is that birds often think they are water and crash into them.
So, we've all heard of wind energy as a form of renewable energy. But what is wind energy exactly? Winds are caused by the uneven heating of the atmosphere by the sun. It is also caused by the irregularities of the Earth's surface. And finally, by the rotation of the Earth. This wind flow, or motion energy, when harvested by modern wind turbines, can be used to generate electricity. So think of it as a reverse frame. So in the case of wind turbines, the wind turns the blades, spin a shaft which connects to a generator and makes electricity. So to calculate the wind power, we need to have the air density, the coefficient of performance of each wind turbine, the area of the wind passing through each blade, and the velocity of the wind. On average, a typical American home would require a small turbine with a 5 kilowatt generating capacity to meet all its electricity needs. A machine of this size has a diameter of approximately 18 feet. The exact size needed to power a home range from 2 kilowatt to 10 kilowatts. Is based on a home's energy use, average wind speeds, and the turbine's height above ground. All of these factors affecting its productivity.
While at the present day, renewable energy sources are not able to generate enough electricity to meet the total global demand, they are both cost-effective enough and efficient enough to be a realistic and conscientious way to generate electricity for residential use.